Hi friends, welcome back to my YouTube channel. So I have already discussed about the physical layer characteristics, and today we are going to learn about the addressing modes in the physical layer or the TCP bar IP protocol. So we have already discussed about the OSI model and TCP bar IP protocol, and the addressing modes are available. There are four types are there, and the physical link address, logical address, port address, and specific address. And this is not important that much, so just it's a introduction for the addressing modes in the available in the protocols. So four levels of address are in used in the internet employing the TCP bar IP protocols. So each address is related to a specific layer in the TCP bar IP architecture. So the physical address means underlying the physical network. It's for the data link layer and physical layer, and the logical address for network layer, and the port address for transport layer, and specific address for application layer. So there are four types of addresses for TCP bar IP protocols, and we are going to discuss about these four in detail. So the first one is physical address. The physical address is also known as link addresses, and it is the address of the node as defined by its LAN or WAN. So there is a communication in between LAN or WAN. The address is for the node defined by its LAN or WAN, and it is included in a frame used by the data link layer. So this address is included in the frame of data link layer, and it is the lowest level address. The main thing is the lowest level address, and the physical address have authority over the network LAN or WAN, and the size and format of these address vary depending on the network. So the size and the format varying depending on the network. For example, the Ethernet uses 6 bytes, that means 48 bit, each bit is 8, so 6 into 8, 48 bit physical address that is imprinted on the network interface card NIC. And also the another example is local talk. Apple has 1 byte dynamic address that changes each time the station comes up. So these are the example for physical address, and the last part defined that the address 6 byte to 12 hexadecimal digits physical address. So this is our first type of addressing, the physical address. And the second one is logical address. The logical address are necessary for universal communications, and physical address are not adequate in an internet network environment where different network can have different address format. So the physical address is not useful for the different networks are connected together, so that time we need logical address. So it's a universal communication address, and a universal addressing system is needed in which each host can be identified uniquely. So each system has a unique address, and that must be that used to identify the system uniquely regardless of the underlying physical network, and the logical addresses are designed for this purpose. So logical address is a universal communication address, and the logical address in the network is currently 32-bit address that can uniquely define a host connected to a network. The physical address will change from hop to hop, but the logical address usually remain the same. So this is a logical address is a constant address. This will not change, but the physical address change from hop to hop. So that's all about the logical address. And the third addressing mode is port address. The IP address and the physical address are necessary for the quantity of the data travel from the source to destination host. So the IP address and the physical address, that means logical address and physical address, are necessary for the data travel from source to destination. A system that sends nothing but data from a computer to another is not a complete. So the system does not only transfer the data from one computer to another. Today computers are devices that can run multiple processes at the same time. So the end objective of internet communication is a process communicating with another process. So today in the internet communication, a process is communicating with another process. For example, a computer can communicate with a computer C by telnet. Telnet is a protocol used in TCP/IP protocol, and at the same time the computer A communicates with the computer B by using file transfer protocol. FTP is a file transfer protocol. And for this process to receive data simultaneously, we need a method to label the different processes. So here we need a method, or we need address for labeling the different process. So in other words, they need addresses. So in the TCP per IP architecture, the label assigned to a process is called port address. So the label assigned to a process is called a port address, and a port address in TCP per IP is 16 bit in length. So that's all about the port address. And the fourth one is specific address. Some applications have user-friendly addresses that are designed for the specific address. So example include the email address and the universal resource locator URL. So for example, www.mht.com, and also the email address, we have an email address regarding this. And for the specific address at gmail.com, so I'll say example for email address. And the first defines the recipient of an email, and second is used to find a document on the World Wide Web, www. So first defines then recipient of an email, and the second defines a document in the World Wide Web. So that's all about today's class. So thank you for watching my video. If you like this video, please subscribe my channel, and thank you. See you in the next video.